Okay, so yesterday we looked at solving equations. Okay, one step, either adding or subtracting. Today it's still going to be one step, except it's either going to be multiply or divide. Okay, so this is what I just said. You don't have to write that part down. So that's what we're going to do today. Multiply and divide. So sometimes when we multiply and divide, we've got fractions and decimals. We might have to use a calculator for some of that too. All right, multiplication property of equality. Okay, we had the addition property of equality, which said you can add the same number to both sides. We had the subtraction property, which said you could subtract the same number from both sides. What do you think this property is? You're allowed to do what? What do you think this property allows you to do? Just basically substitute that word in. Yeah, you can multiply both sides of an equation by the same number. Okay? And Mr. Wright, they're just listening to this part, right?
Yeah, I'm just listening to that, guys. I'm not writing anything down yet.
You are allowed to multiply both sides of the equation by the same number. There is only one number you are not allowed to use. What number can you not multiply both sides by? Because if you did this, it would wipe out your equation. You'd have nothing left. Ryan?
0?
Yeah. You can't multiply both sides by 0. Okay? Imagine you had an equation like, let's say, 2x equals 10. If you multiplied both sides by 0, you'd wipe this out, you'd wipe that out, you'd have nothing left. That's why you can't do that. Okay? And as long as you multiply both sides by the same number, you get an equivalent equation. So our goal is going to be to take an equation that has a number next to the x and get rid of that number. All right, so let's, yeah, that's fine. Let's go to this. Okay, if you have a fraction, as a coefficient, okay? What's a coefficient? You remember what is?
Remember talking about that a little bit last week, I think Friday.
You remember what a coefficient is?
Somebody give me an example, not of a variable with a number. Go ahead.
Caitlin?
Well, like the number connected to a variable?
Yeah, exactly. It's the number that's connected to the variable, the number that's right in front of it. Okay? So,
I'm on this, David.
yeah.
Caitlin, what did you just do?
I looked in my notes.
Oh my God. It's a miracle. What are we on the fourth day? Fourth day? We got people looking in their notes. We got that very, only a few times last year, Miss Dave.
I know.
It's a breakthrough.
That's perfect.
Caitlin, you made my day. Doesn't matter what happens from here on out. I'm good.
All right, so that's perfect. She looked it up in her notes. Coefficient, that's the number in front of the variable. Does anybody know what I'm going to write next here? You might have seen this before. All right, let me show you an example. Maybe that'll kind of jog your memory. If you had something like this. Does anybody know how you would get x by itself here? I kind of gave it away part of it. You're going to multiply both sides by something.
Some active people today.
He doesn't know it. He doesn't know it.
Oh, I know it. How you know you remember it? You know?
Now, Callie, not sure?
He doesn't know it.
I do know it.
Samantha, what about you? You think you know?
Oh.
So you multiply both sides by what? Not 2/3. Close. Yeah. You flip it. Yeah, well, so what is that called? What's that word? We practiced it just 5 minutes ago. The reciprocal. Yeah. Okay. So if you've got a fraction in front of a variable, you're going to multiply each side of the equation by the reciprocal of that fraction. All right? And what that's going to do is it's going to give us a way to get rid of the 2 and the 3 at the same time.
What if that fraction was negative Ariana, what if the fraction was negative? What do you think? What do you think?
It's still flipping,
So,
yeah.
yeah, but would you, when you flip it, do you keep the negative or do you get rid of it? Keep it, right? We're not doing anything like that yet. Keep that negative sign. Don't let it throw you off. You're only flipping the fraction. You're not doing the opposite of what the sign is. So keep the negative sign.
All right, so let's practice that and see if you guys got what Mr. Roy just said. Here's some fractions, okay, and I want to write their reciprocals. Alex, what would be the reciprocal of 5 halves? 2 over 5. Good. Okay, how about negative 3/4? What would be the reciprocal of negative 3/4? Yeah, Gabe?
-4.
Perfect. Okay, he did exactly what Mr. Roy said. Keep the sign the same, flip the fraction. Okay? How about 2 divided by A? Okay, now we got a letter in there, but don't change how you do it.
Go in my hand, right?
Ryan?
A divided by 2.
Yeah. A divided by 2. Is that good, Mr. Roy? Is that versus like a 9? Make my 9s like that for you?
I can't say my handwriting's pretty bad too.
All right, so 2 divided by A divided by 2. Okay, one more. How about B divided by C? Caitlin? C divided by B. Okay, so it doesn't matter what the fraction is. You just take and you flip it. Whatever's in the top, bottom, whatever's in the bottom, put in the top. So any questions on what a reciprocal is?
You guys good with that?
All right, so Mr. Roy's going to talk a little bit about this stuff.
All right, guys. So on your sheet, on your note sheet, we're talking about multiplying or dividing. All right, now we're still doing one-step equations like we did yesterday, but instead of adding and subtracting, we're multiplying and dividing. All right. So first thing I want to do, all right, just like we did yesterday, same first step as we did yesterday. We want to find the number with the variable, and like we just talked about, when we're doing this, it could be a fraction. All right? Because what is, I know a fraction is like a number over a number, but what math operation, Ben, is that representing? A fraction. What math operation is that?
Division.
Division, right? Any fraction is division. You got that, Algarin? Say it. Any. Oh, yeah, you can say every, so that's fine. Yeah, any or every fraction is a division. All right, if you put 3 over 4 in your calculator, you'll get like 0.75. All right? So any fraction can be divided. So if you get a bigger number, I always say, if you get a bigger number on the top, small number on the bottom, see if the smaller can go into the bigger. It's easier to work with whole numbers than fractions. Okay, and always see, most times you're going to always see if you can reduce those too. See if there's a number that goes in the both. Okay? Next. We're going to multiply or divide by that number, right? The number that's with the variable, or it could be a fraction, and we'll do it on both sides of the equal sign. Right? So rather than adding or subtracting like we did yesterday, we're going to multiply or divide on both sides of the equal sign. And guys, what's that called again? The number we talked about it maybe 3-4 minutes ago. The number attached to the fraction is called what? Sam?
Coefficient.
Yeah, coefficient. So if you don't know that, as long as you know that you have to divide by or multiply by the number that's attached to the variable. Very important. Okay? Next. If it's multiply, right? You're going to multiply if a whole number is with the variable. Like I have here. 4 or negative 22. 1,000. 1,001. 1,264,000. Whatever. Right, whatever is if it's a whole number, it's attached to that variable, you're going to divide by that. Divide by whatever number that is that's attached to the variable. That's when you have to multiply. All right, give you guys another second to get that written down. Still see some pencils moving, so. I'm sure you guys have done stuff like this before, middle school, hopefully. Next, we'll divide, just like we talked about in the warm-up, just like Mr. Hager just showed you, all right? We will divide, which people already said, we can, some people say flip the fraction, that's fine. Some people get all high-tech in math and say reciprocal. Either one works. However you remember it, that's fine. Right? Either flipping it or it's reciprocal. Remember, keep the sign. Don't change the sign. We're not at that point yet. You don't have to. Don't change the sign. If it's negative, keep it negative. So in this case, the example, like we just did with Mr. Hager, 2 over y, it'll just become y over 2. I'm just flipping. Again, keeping the sign. I know I sound like a broken record, but people still do that. Right? So we got multiply and divide. Then simplify. Like we just did in the last, I think we had the 3/4 one we just did. All right? It's going to simplify. We'll actually do our division or our multiplication, depending on what the problem asks for. So simplify, we'll do whatever operation we have to do, multiply or divide. That's all we're going to see today, is this multiplication or division. I think.
One more.
Is there one more? And then, like we did, guys, yesterday, check. We'll probably do the same thing we did like last night's homework, where we checked 4 or 5 of them. Again, as we get going here, we're not going to make you guys check. All right? Everybody good with this? Anybody need a little bit more time getting this down? Okay. So right next to that, you see an example, right? So I got x over 4 equals -7. I'm going to write it right next to it. X over 4 equals, what was it again? -7, guys? -7. Oops, that's a bad 7. I don't know what the heck that was. That was pretty bad. All right. This is example, what is it, 1A on your notes? Or just 1? Right, yeah, right, I want to put it right next to the example, so you have one to look at. All right, so here's that problem. So, Mr. Newman, what are we going to do first? What's the first step say to do? I'll leave them all up there.
Find number with variable.
Yeah, and it could be a fraction, right? What's your variable? X is my variable. Thank you, Mr. Newman. Keeping it simple for you this morning, my man. Next. Alex, what's the next thing we got to do? What's the next step, sir? So we did this. We found the number with the variable. What's the next thing we got to do?
Multiply or divide.
Multiply and divide by that number. So Alex, what's this problem call for? Multiplication or division?
Division.
Now remember, this represents division, right? Something over something represents division. So think back to people that were here yesterday. Think back to yesterday. When we had, Ariana, when we had addition, how do we get rid of it? Subtraction, right? Ryan, when we had subtraction, how do we get rid of it? No, when I had subtraction yesterday, how did I get rid of it? Add, right? Those things are what? Opposites, right? So, think what those people just said, all right? Alex, we had x over 4, right? Or x divided by 4. So originally, I have division. So what am I going to do? Multiplication. Better. Always the opposite when we're doing equations. So I'm going to multiply. There's my dot. I got to do it on both sides, right, Alex? Awesome. I'm going to multiply on both sides. Multiply by what, Alex? You think you know?
4.
Multiply by 4. Even though there's an x here, I mean, we can pretend there's a 1 with it. All right, we're just going to flip it, put 1 on the bottom. Okay? So we'll multiply by 4 over 1. Same thing over here. Multiply by 4 over 1. So I did that second step. All right, I multiplied and divided by that number. We knew it was we knew we were gonna. Right? We have a fraction, right? We know we're dividing because we have a fraction. Right? Now I'm just going to do the math. On this side, everything's just going to cancel out. That's why I did it. Like I told people last year. We're not just dividing by a fraction and say, hey, I'm really good at math and I like to work with fractions and multiply by fractions. No, because we want to get the variable by itself. All right? So I'm left with x. Now, Michaela, what are we going to get? What's x going to equal? Do you know? Can somebody, Alexis, make sure you tell me the sign too. What am I multiplying by on this side of the fraction? Or this side of the problem, I'm sorry. That side of the equation. Yeah, -7 times 4 to 1. I can put this over 1, 2 if I want, but it's really -7 times a positive 4. So Michaela, I know you can help me out with this. I got a negative times a positive. There's no sign there, so I know it's positive. What's your final answer going to be? Negative, right? What's the rule? Okay, she doesn't know it. What's the rule? Who can help out Michaela? Sam?
Negative times a positive is a negative.
Yeah, negative times a positive, always a negative. Thank you, Michaela. So then what it's going to do is 7 times 4. Now, Garen, what do I get? -7 times a positive. I already get the negative side. This 7 times 4. 28. Here's my -28. Now, we just did that part. We just simplified. We did the math. In this case, we did the multiplication. We did the math. Now we're at that check part. Calvin, how would I set that up? What would that look like? Say it again. -28 over what? 4. On the other side? Equals -7. Calvin, what's this mean again? What's this mean? Divide, right? What do you get when you do this and this?
7. -7.
Awesome. Right? -7 equals -7. It checks out. All right? I got a negative divided by a positive. Because there's no sign there, and it's assumed that's positive. Everybody good with this? Everybody okay with this? Everybody feeling like they can handle this? Everybody awake? Someone. All right, let's go to the next one. Next slide. We just did this one, guys. 1A, we don't have to worry about that. Next, 2A says solve and check. I want you guys right now, write this down, solve it. Write this down, solve it on your own in your notes. Similar to what we just did, but last one we had a number and then a variable on the bottom. This one we have numbers on both the top and the bottom, as a numerator and the denominator. Logan, my main man from downtown. What are you gonna multiply? What are you gonna multiply by?
You're going to multiply by
Can you give me the sign too, please?
positive 2 over 3.
Anybody? Any agrees out there? You said, say it again, Logan. What'd you say again?
I said positive 2 over 3.
Positive 2 over 3. Anybody see a problem with that?
I think you should flip it.
I like that. I like what Gabe said. Flip it. So when I flip it, Gabe, what would it be?
3 over 2.
3 over 2. Sweet.
Negative 3 over 2.
Ooh. Nice touch. 3 over 2, and like I said, that's why I said don't get tricked by the sign. Davin, you with me? You alive? You alive and well? Right. Negative. We don't have to change the sign. We're not at that point yet. Don't do more than you need to. Right? Don't overthink it. You don't have to. Right? Don't overthink it. You got it? Can you help me with this last part? She's like, I guess so, right? So what's gonna happen over here? It's going to be gone, right? What's going to be left? Here's my equal sign. What's on this side? Y. Sweet. Other side. What do you got to do? So,
Put the 6 over 1.
6 over 1. I love it. All right.
And then times it by -3.
Oh, and a negative. bring it in, she's bringing it in. All right, what can I do here, Sabrina?
Cross.
Cross? Let's not do more than we have to.
3 times 1.
I want to do it a different way. Victor, is that you raising your hand? You just stretching back there. Oh, Vic, give me it, man.
Would it be 18 over 2?
18 over 2. What you do? How'd you get that, Victor?
You multiply it?
Yeah, let's multiply this way. We're not at that cross multiplying part yet, Sabrina, but I like the way you're thinking. All right, this. Anybody see anything else? Brian,
You could,
I know you're going, but before you even get there, one thing.
Reduce.
Nope. Nice.
Oh.
Right? We forgot to put our negative. We didn't put our negative, right? So we had a negative 3 over 2 and a positive 6 over 1. Now, Ryan, we can do what you want to do.
simplify.
By what number?
By 2.
2. Divide by 2, divide by 2. On the top, Ryan?
Is, set, 9.
9. Bottom?
Is 1.
1. Does this what's the sign? Even though we reduced, the sign doesn't change. All right, don't do more than you have to. What is that really? Sam?
-1.
-9. Anything over 1 is itself. All right? Right, you got that? Sure? All right. Anything over 1 is itself. -9. Excellent. Okay? Done. So, do you want to check this one?
No, that's okay. We don't have to check.
Yeah, you don't have to check this one. It's gonna work out. All right? Good? Logan, good?
Yeah.
Feeling good? Good. You guys, everyone got this down in their sheet, right?
Yes.
Yes. All right. We're getting there. Ooh. Mr. do you want to do this?
There's no example.
So before Mr. even gets there, right? We just did problems that we had to use what for? Who can tell me? What math operation do we have to use?
Multiplication.
Multiplication, right? So what do you think this equality is going to be?
Division.
Division, right?
Okay, so based on what we've done before, anybody think they can tell me what the division property of equality allows you to do? We've done it with adding, subtracting, multiplying. Same idea here.
There was a word that we used, right? Mr. Hager, the word you're looking for. Starts with an E.
What are we allowed to, yeah? Not evaluate, but this is going to be a step when we're solving an equation. What do you,
It starts with the first 2 letters, EV.
Evaluate.
No, it's EQ, right?
maybe. What is this going to allow us to do? Yeah.
Evaluate.
Nope, not evaluate. So think about, what did the addition property of equality allow us to do?
Equal.
What do you mean equal?
It's so similar to that word.
Equivalent. No.
So the addition property of equality allowed you to add the same number to both sides of an equation. What about subtraction property?
Subtract numbers to both sides.
Subtract the same number from both sides. We just did multiplication. You can multiply both sides by the same number. So what do you think this one is?
Divide
Where?
on both sides.
Yeah, the division property of equality says you can divide both sides of an equation by the same number, any number you want, except what number are we not allowed to divide by in math? 0.
Yeah.
Any number except 0. Okay, so you are allowed to divide both sides of an equation by any number you want except 0, and you will get an equivalent equation. Meaning you won't mess anything up. All right? So let's take a look at this one. 18 equals 5x. Okay, it's example 3a on your note sheet. All right, what operation am I doing on the right-hand side? Yeah, we're doing multiplication. So what's the opposite operation of multiplication? Victor?
Can you say that again?
What's the opposite of multiplication?
Division.
Division. Okay. What can we divide by to get rid of the number next to x?
5.
Itself, so cancel that one.
Right, you divide by that number that's next to x, so we cancel it out. What's that number called?
Coefficient.
Yeah, the coefficient. Nice. 5 divided by 5.
So Mr. Hager, what
gone.
you're saying is, anytime there's a number with a variable attached, that means division? I'm sorry, multiplication?
That means multiplication.
Okay.
Yep. Fractions are the only one we treat a little differently. That's where we multiply by the reciprocal. That's like a special case. Okay, but any other time we just have a number attached to a letter, we divide by that number. Okay. How about, Alex, what do I have on the right-hand side now?
Thanks.
Yep, x. Now, 18 divided by 5. Caitlin, does 5 go into 18? No, it doesn't go in evenly, so we just leave it. Okay, we're done. Don't worry about changing it to a decimal, mixed number, none of that. Just leave it as 18 divided by 5. Okay, if Mr. Roy and I want a decimal, we'd let you use a calculator. Okay. Any questions on that? That's it. All right. Is there another?
Yeah, you guys this fall, you don't have to write this one down, just kind of follow along with this one.
Okay, who thinks they can tell me what to do here without me explaining too much? What are we going to do? And try to tell me why you're doing that. Yeah. Okay, okay, you are going to divide. How do you know that?
Because you're multiplying.
Right, you're multiplying. 0.8 times x. Okay, somebody else tell me, what are you going to divide by? Sabrina. 0.8. And we're going to divide by 0.8. Right, so 0.8 divided by 0.8, that's gone. And now on the left-hand side, Zach, what do I have left there?
X.
Good, x. Right-hand side, easiest thing, let's just type it in the calculator. Okay? So take 24 divided by 0.8. 30. So we get 30. Any question on that? Okay, we've been a little lazy. We haven't checked any of them, so let's check this one. All right, since we can just use the calculator. Yeah, Sam, how do I check it?
0.8 and then substitute 30 in for x.
And we're going to hope that that equals what?
24.
Yeah. We're going to hope that when we plug our answer back in for x, multiply by 0.8, hopefully we get 24. Let's check it. 0.8 times 30, 24. So we're good. It checks. Okay, any questions on that one? Okay, word of. We've seen the word of a lot. Okay, of, you see of, that means multiply. Right? So if I said to you, what is 2/3 of 12? Okay, the way you could figure that out on a calculator is 2/3 times 12. Just change the word of to times. Okay? And I think we've gone over that, right, Mr. Roy?
Yeah, we talked
Yeah,
about that.
we've seen that
It's
before.
on the shot, they got second day.
Okay, so you guys they already have that? You're good?
Yeah, I mean, it's not on there, but we talked
We
about it.
talked about it. All right, so let's see this one. Okay, so I think this will be our last one, and then we'll have you guys practice some on.
Yeah, guys, we'll just go over this one. Let's gotta pay attention with it.
Okay, it says Joe ran 3 miles. Joe ran 3 miles. So the distance that Joe ran is 2/5 of the distance that Mike ran. Okay, how far did Mike run? Okay, how far did Mike run? Okay, sometimes when I see it worded this way, sometimes I rewrite it. I start to rewrite it in a way that's a little bit closer to an equation, and it makes a little more sense in my head. Because sometimes I see all these words, and you get confused. All right. So let me show you how we can rewrite it. So we've got Joe's distance is, okay, I'm going to write it that way. Joe's distance is 2/5 of whose distance?
Mike's.
Mike's distance. Mike's distance. So basically what I did there is I kind of reworded it, took out some of the words we didn't need. Let's take a look. Does everyone see how I reworded it, but it's basically the same thing?
Don't we need 3 miles in there then?
Yep, we're going to need the 3 miles in a second too. Okay, so Joe's distance is 2/5 of Mike's distance. And exactly what Sam just said. How much is Joe's distance? What's Joe's distance in this problem?
3 miles.
3 miles. Joe ran 3 miles. Okay, so all of that is 3. Okay, how about the word is? Does anybody remember what that is? Yep. What is it? Equals. Good. Okay. 2/5. Well, that's just going to stay the same. How about of?
Equal. I mean, multiply.
Yep. So multiply. And what about Mike's distance?
Add.
Sure, we could just call that M. Okay, so we basically have our equation right here. 3. What's going to come next?
Equals.
Equals. Joe's distance is what?
2/5.
2/5.
How is that?
Of, we just said means times. Mike's distance. We said that was M. That's it. Okay. So it does take a little bit of practice to kind of learn in your head how to work with a word problem and simplify it. But that's all you have to do. Okay.
You guys, there's only a couple of these there's only 2 word problems on the homework tonight.
Okay, now from here, this should be the easier part. How do we get M by itself? Keep in mind, we've got a fraction in front of the variable. So we talked about, this was maybe one of the first ones we did. Sabrina? Okay, you could divide each side by 2/5. Bless you. That's perfectly correct. Or, instead of dividing by 2/5, that's the same as what? Sam?
Multiply by the reciprocal.
Multiply by the reciprocal, which is
5 over 2.
5 over 2. And we have to multiply by 5 over 2. When you multiply 2/5 by 5/2, those cancel each other out. And how about, Davin, what do we have left on the right-hand side?
Well, what do you mean?
Is there anything left on the right? That's confusing, right? Is there anything left on the right? Is there anything on the right-hand side that's still there? Yeah, just the M. Okay. And now this other side. Sam, what do I do here? 5 times 3 is 15.
And 2 times 1 is
Yep, so she, in her head, she just put it over 1. 2 times 1 is 2. So that's how far Mike ran. How far is that? You could say it's 15 halves.
7.5.
Or that's 15 divided by 2. That's 7.5 miles. Okay, what did I have to do? I was going to ask you guys, but I already did it. What do I have to do because it's a word problem when I write my answer? And it's part of what's in that circle. Yeah, Caitlin?
You have to label it.
Right, I've got to label it. Okay, whatever the problem has to do with, whether it's miles or money or time, just make sure you throw a label on there. Okay, any questions on that? All right, so we're going to give you guys some problems to practice on in class. Okay, but for tonight, we'll give you a worksheet on section 3.2. Make sure you still get your binder for Friday. Also, I counted up the forms for the dean's office. I think I only have 19. So I'm missing like 8 or 9 of those blue forms. All right, if you have those, make sure you get them in. Otherwise, the deans are going to start giving you demerits. Okay?